Let's understand text extraction and pre-processing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and pre-processing n-grams. Now let's look at what n-gram is and how it is helpful in text mining. N-gram is the simplest model that assigns these probabilities to sequences of words or sentences. N-grams are combinations of adjacent words or letters of length n in the source text. So n-gram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, and a 3-gram or trigram is a three-word sequence of words like this is a, or is a sentence. Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from nltk.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English. So use set function as set under braces, stop words dot words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and pre-processing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and pre-processing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or a morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and pre-processing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number, either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here, Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE, or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc. based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language